Hello friends, we'll discuss the classification of circuit breakers. The classification of circuit breakers, it is based on the various voltages in the electrical system from generating station up to the distribution level. The location of circuit breaker in the substation, the external design of the circuit breaker, interrupting medium of circuit breaker, so arc interruption medium based on that, operating mechanism while opening and closing the contacts of the circuit breaker, what type of mechanism we are using, based on that the circuit breakers are also classified, and based on the number of poles. So generally our electrical supply system, it is a three-phase supply system, and based on that number of phases used for the particular application, so it decides the number of poles. Okay, based on that the circuit breakers, they are classified. So these are the various parameters. Based on these parameters the circuit breakers, they are classified. Now we discuss this classification of the circuit breaker based on these various parameters, how they are classified, what are the different types of the circuit breaker. So first we start with this voltage level. So based on this voltage level, the circuit breakers, they are classified as low voltage circuit breaker. The voltage level is less than 1 kilovolt. The circuit breakers, they are used below this 1 kV. They are classified or categorized as low voltage circuit breaker. Next is medium voltage circuit breaker, MV circuit breaker. So it ranges from 1 kV to 52 kV. So this is the range of medium voltage circuit breakers. Generally this medium voltage, it is used in the distribution of electrical power. Next is high voltage or extra high voltage. So it starts from 66 kV to 765 kV. So these voltage levels, it is high voltage or extra high voltage circuit breaker. It ranges between 110 kV, 220 kV, 400 kV, 765 kV. So these are the various voltage levels. They are used in the transmission of electrical power. Next is ultra high voltage, above 765 kV. They are called as a ultra high voltage or UHV. So based on this voltage level, the circuit breakers, they are classified as LV circuit breaker, MV circuit breaker, HV or EHV circuit breaker, and UHV circuit breakers. So this is a classification based on the operating voltage of the circuit breaker or rated voltage of the circuit breaker. Based on the location of the circuit breaker, they are classified as indoor type circuit breaker and outdoor type circuit breaker. Indoor type generally in the distribution substation or at the incoming supply at the industry. The circuit breakers, they are used as a indoor circuit breaker. So in a large room or hall, the circuit breaker panels, they are mounted. So they are called as a indoor type circuit breakers. Generally these circuit breakers, they are mounted in the panels. So medium voltage, low voltage circuit breakers, they come under this indoor type circuit breaker. Nowadays, GIS, gas insulated substations, they are also indoor type and outdoor type. So outdoor type means these circuit breakers, they are mounted in the open switchyard, okay, and they are open to the sky. So this is outdoor type and indoor type circuit breakers based on the location. Next is based on the design, external design of the circuit breaker. So in circuit breaker, so we open the contact in the normal current or at the rated current, and when there is an abnormal condition, at that instant again we are also isolating the faulty section, so contact they are open. So arc is generated while opening the contact of the circuit breaker, and for interruption of this arc, so arc interrupting medium they are used. This is a basic function of the circuit breaker, but these arc interrupters, where they are placed, okay, so based on the construction of this circuit breaker, they are classified as dead tank circuit breaker and live tank circuit breaker. So based on the external design of the circuit breaker, they are classified as dead tank and live tank circuit breakers. For this interruption of the arc, we are using the different mediums to take the heat or the ionized gases away from the arc interrupter. Air brake, atmospheric air is used to interrupt this arc. Air brake. Air blast, high pressure air, it is injected on the arc so that the hot gases, ionized gases, they are taken away from the contacts or from the interrupter. So high pressure, it is injected. So it is called as a air blast. Oil is used as a arc interrupting medium. Then SF6 gas is used as a arc interrupting medium, SF6, sulfur hexafluoride. Then vacuum. So based on this arc interrupting medium, they are classified as air brake, air blast, oil circuit breaker, SF6 gas insulated circuit breaker, and vacuum circuit breaker. So these are the medium which interrupt the arc. Then we'll see the further classification of this air brake circuit breaker, air blast circuit breaker, and oil circuit breaker. So this air brake circuit breaker, they are further classified as air circuit breaker. This is a 3-pole or 4-pole. Generally this 4-pole, it is used for the generator or for this change over between utility supply and the generator supply. Then molded case circuit breaker, they are called as MCCBs. Miniature circuit breaker, MCBs. Residual current circuit breaker, RCCB. Earth leakage circuit breaker, ELCB. So these RCCB and ELCB, they are used for the protection of the devices from the earth leakages. This MCB and MCCB, they are used to protect the devices from overload condition and the short circuit condition. Air blast circuit breaker, again it has the protective devices like earth leakage release that we can use, under voltage release, overload and short circuit thermal release. So with this ACB, we can mount these various protective devices. So these air brake circuit breakers, they are used for low voltage level. They are used for this low voltage level LV. Then air blast circuit breaker, based on the arc interruption or the direction of air blast, air flow on the arc, they are classified as axial blast and radial blast. And axial blast and radial blast. Oil circuit breaker, depending on the quantity of the oil in the circuit breaker, they are classified as bulk oil circuit breaker and minimum oil circuit breaker. So these are the classifications, further classifications of air brake, air blast and oil circuit breakers. Based on the operating mechanism, circuit breakers, they are classified as a spring mechanism, pneumatic mechanism, hydraulic mechanism, motor driven mechanism and SF6 gas dynamic mechanism. Contacts, they are separated. In the circuit breaker, there are two contacts. One is fixed contact and another one is moving contact. So this moving contact, it close or it open the circuit. And for the movement of this moving contact, so there is a mechanical design is there or mechanical circuit is there, springs, gears, so these are provided. All these three poles, they are linked with each other so that the three poles, they open simultaneously. Based on this movement, what type of mechanism we use to open or close the circuit breaker, they are classified as spring mechanism, pneumatic mechanism, air pressure, it is used to close and open the circuit breaker. Hydraulic fluid is used. Then motor driven, say stepper motor, it is used. Then SF6 gas with the control valves and the cylinders, this SF6 gas, it is used to close and open the circuit breaker. So based on this operating mechanism, spring, pneumatic, hydraulic, motor driven and SF6 gas dynamic mechanism, they are used to open or close the circuit breaker. Depending on the number of poles, the circuit breaker, they are classified as single pole, double pole, triple pole and four pole. In the transmission and the distribution of the electrical power, the triple pole circuit breakers, they are used at ultra high voltage, extra high voltage and medium voltage and low voltage circuit breakers. Three poles are there. Depending on the application, like for changeover of supply from utility to DG or from DG to utility at low voltage level, we have to isolate the neutral connected to the load from the utility when it is connected to the generator, is supplying power to the load. So the neutral of generator, it is connected to the load. And when we shift from generator or DG supply to the utility supply, again we have to use the neutral from the utility side. So in that case, we are using this 4-pole circuit breaker. At domestic or commercial level, we are using single pole MCBs in single phase supply system to isolate the phase and neutral. Double pole MCB, they are used. So depending on the number of poles, again in the electric locomotive, single pole circuit breaker, they are used at the rooftop of the locomotive. Then double pole, for the traction substation, the two poles are there. One is connected to the overhead catenary and another it is connected to the ground of the rail. So in that case, double pole circuit breakers, they are used. So based on the application, the circuit breakers, they are classified as a single pole, double pole, triple pole and 4-pole circuit breakers. Now we'll see the classification in details based on the location of the circuit breaker. So medium and low voltage switch gears and high voltage gas insulated switch gear, GIS. So they are mostly categorized as indoor switchgear. So here in this picture you can see this is a panel, and on this panel these switchgears or circuit breakers, they are mounted on this panel. So this is a low voltage switchgear, low voltage circuit breakers. Similarly, for medium voltage circuit breakers, they are trolley mounted at the bottom portion of the panel. The next picture, it shows the gas insulated switchgear, GIS. So this GIS, it is also indoor. Okay, so based on the location of the circuit breaker in the electrical system, they are classified as a indoor switchgear or categorized as a indoor switchgear. So in the next picture or third picture, you can see this substation. It is a air insulated substation, AIS, air insulated switchgear, and they are open to the air, and they are categorized as a outdoor switchgear. So where we are going to use the circuit breaker, depending on the location of the circuit breakers, they are classified as indoor switchgear and outdoor switchgear. Okay, so based on the location of the circuit breaker. Then next classification is based on the external design of the circuit breaker. So this is for the outdoor type circuit breaker. This external design classification means dead tank or live tank circuit breaker. It is only for outdoor type circuit breakers. Okay. So outdoor circuit breakers can be identified as either dead tank or live tank type circuit breakers based on their physical structural design. So based on the construction, physical structural means construction, how they are constructed, how they are mounted. So in dead tank circuit breakers, the switching device is located with suitable insulator support inside the metallic vessel at ground potential and filled with insulating medium. Switching device means the fixed contact and moving contact or the arc interrupting device. Okay. So which will make and break the circuit, that is called as a switching device. So this switching device with the insulator support, they are mounted in the metallic vessel. Okay. So here you can see this is a cylindrical tank, and in this cylindrical tank the contacts, they are placed here. These contacts, fixed contact and moving contact, they are placed here so that they will interrupt the arc and isolate the circuit in normal condition or abnormal condition. And this tank, it is at the ground level, zero potential. It is connected to the earth, so that it is called as a dead tank. So these switching devices, they are placed in the metallic vessel with the help of insulators, and this metallic vessel is at the ground potential and it is filled with the insulating medium. So generally the oil, it is used in this dead tank circuit breaker, and incoming and outgoing conductors, they are taken out through the suitable insulator bushing. So incoming and outgoing terminals, they are connected to this switching device with the help of this porcelain bushing. It is connected with the porcelain bushing. And at the bottom of the bushing, or at the end of the bushing, end towards this metallic cylinder, the current transformers, they are mounted here, and they are called as a turret city. So current transformers, they are placed here for the measurement of current or for step down of current. So you can see here, as compared to this live tank circuit breaker, the more space is required for this dead tank circuit breaker. And to minimize the space, these current transformers, they are placed on these bushings. Then next is a live tank circuit breaker. The interrupter is located in an insulator bushings above the ground potential. So in this live tank circuit breaker, so you can see here the incoming and outgoing terminals, they are connected to this horizontal bushing. And in this horizontal bushings, moving contact or switching contacts, it is provided here. And this is at the higher potential. This is at the higher potential, which is more than the ground level. So these interrupters, they are supported with hollow porcelain insulator. And through this hollow insulator, the moving contact, it is connected to the tripping mechanism. It is connected to the tripping mechanism. So live tank means the interrupter is at the higher potential. They are at the live potential. They are not connected to the ground. That's why they are called as a live tank circuit breaker. So from this construction, you can conclude or you can analyze that these live tank circuit breakers, they are cheaper with no current transformer. So in this dead tank circuit breaker, current transformers are there. Then overall size, space required, it is more. For live tank, less mounting place is required, no cities. So because of this, it is cheaper. So based on this external design, this is a classification or types of the circuit breaker: dead tank circuit breaker and live tank circuit breaker. Now we see the oil circuit breaker, classification of oil circuit breaker, bulk oil and minimum oil circuit breaker. So this bulk oil is a first generation of the circuit breaker. So it required a large quantity of oil for arc extinction. That is called as a bulk oil circuit breaker. BOCB, bulk oil circuit breaker. And as you can see here, the bulk oil circuit breakers, they are also called as a dead tank circuit breaker. They are also called as a dead tank circuit breaker, because this oil tank, it is held at the ground potential. Depending on the voltage system, the quantity of oil required, it changes. For 110 kV, 8 to 10,000 kilogram of oil is required for this oil circuit. And from this quantity, 8 to 10,000 kg, or for 220 kV, it is a 50,000 kilogram of oil. From this quantity, you can see that it is called as a bulk oil circuit breaker. And in this oil circuit breaker, the oil is used for arc extinguishing medium, and it is used as an insulator to insulate the live parts of the circuit breaker from the earth, like transformer. So in the transformer, the windings, they are insulated from the tank. So the oil serves the two purposes: arc extinction and insulation of live parts. So next is minimum oil circuit breaker, MOCB, minimum oil circuit breaker. So as compared to the bulk oil circuit breaker, it requires 1/10 of the total oil. That's why it is called as a minimum oil circuit breaker. So after degradation of this oil, we need to filter this oil. So it costs very high. Sometimes if there is a blast in the circuit breaker, so these thousands of kilograms of oil, it is wasted. So that's why the bulk oil circuit breakers, they are modified, and next is a minimum oil circuit breaker. So this minimum oil circuit breaker, it used as an arc quenching medium, and it is mounted on a porcelain insulator to insulate it from the earth. So on the vertical portion, this arc interrupter, it is used, and it is mounted in the porcelain insulator, so that naturally the size of porcelain insulator, it is less, and the oil required to interrupt the arc, or for the arc quenching, or for arc extinguishing, the oil required, it is 1/10 of that bulk oil circuit breaker. The arc chamber of such a type of circuit breaker is enclosed in the bakelized paper. Okay, bakelized paper means it is a kraft paper, layers of kraft paper, and it is impregnated with phenoplastic resin, so that the insulation level of this bakelized paper, it is increased, and it also supports for this porcelain insulator. So in this bakelized paper, this arc chamber, it is used, or it is the lower portion of this breaker is supported by the porcelain, and the upper porcelain, it is enclosed the contact. So on this vertical arrangement, porcelain insulator, these minimum oil circuit breakers, they are mounted. Next is classification of air blast circuit breaker. According to the type of flow of air blast, this circuit breaker, it is classified as axial blast and cross blast. Axial blast type, blasting of air is done directly along the path of the arc, means parallel to the arc. Air is blast parallel to the arc. So this is fixed contact and moving contact. Between these two contact, so there is an arc, and air is flow parallel to this arc, so that the ionized particle between this fixed and moving contact, or in this interrupter, so it is taken away, and fresh air is placed as a dielectric between these two contacts. So this is the most common type of air blast circuit breaker, employing axial flow of blast air for extinction of arc. Next is a cross blast. So in this cross blast type circuit breaker, air is blast perpendicular to this arc. It is blast perpendicular to the arc, and on the opposite side, the arc splitters, they are placed here, so that this arc is elongated in this arc splitter, so that the resistance of arc, it is increased, and at the next current 0, the arc is interrupted. So this is called as a cross blast or the radial blast. And third one is a combination of both axial and cross blast. So the air blast, it is moving through this hollow, fixed and moving contact. So this is a combination. So air blast circuit breaker, they are classified as axial blast and cross blast type circuit breakers. Now we'll discuss the air brake circuit breaker, which is used at low voltage. air brake circuit breakers come in with different ratings as different circuits utilize different current and voltage rating. So this air brake circuit breakers, air circuit breaker, molded case circuit breaker and MCBs. Based on the current ratings, these circuit breakers, they are divided. Overall, the dimension, overall size, overall construction of these circuit breakers, it depends upon the current ratings of the circuit breaker. For 400 ampere to 1600 ampere, and it is used up to 6300 ampere current rating. So this is a rated current of the air circuit breaker, and they are available in 3-pole or 4-pole. So air circuit breaker 400 ampere to 6300 ampere, panel mounted, fixed type or draw out type. They are used for the low voltage. Next is a MCCB, molded case circuit breaker. So it starts from 63 ampere or 100 ampere up to 1600 ampere or 2000 ampere current rating. They are called as a MCCB, molded case circuit breaker. So these are also available in 3-pole or 4-pole. Next is MCB, miniature circuit breaker. And the current rating of this MCB, it lies from 2 ampere to 125 ampere. So these MCBs, they are available in single pole, double pole, triple pole or 4-pole. So based on the current ratings, this air brake circuit breaker, they are classified as air circuit breaker, molded case circuit breaker and miniature circuit breaker. So these circuit breaker, they are having their own current range and there is some overlapping. Say here MCBs, they are available up to 125 and MCCB, they start from 63 to 100 ampere. So some portion of MCB and MCCB's current rating, they are overlap. Here you can see air circuit breaker, it starts from 400 ampere. So some portion from 400 to 1600 or 2000 ampere, it is an overlap between MCCB and air circuit breaker. So here you can see the actual pictures of the air circuit breaker. This is the air circuit breaker. On this air circuit breaker, the spring mechanism is there for closing and opening of the circuit breaker. This is the microprocessor based relay for overload and short circuit protection. This is open and close push buttons are there. Next is a MCCB, molded case circuit breaker. So this is a molded case circuit breaker, MCCB. So in this MCCB, microprocessor based relays, thermal relays, it is available. Single pole, double pole, triple pole and 4-pole MCBs, miniature circuit breaker. And here you can see double pole and 4-pole RCCB or ELCB. So this is the classification of air brake circuit breakers which are used in low voltage. Based on the operating mechanism, we'll see the various types or classification of the circuit breaker. The basic function of the circuit breaker is to interrupt the flow of current in the fault condition or abnormal condition, or when this fault is detected by the protective relays, and protective relays, they give the tripping command to the circuit breaker. So during this fault or abnormal current, which is in thousands of ampere, a heat is generated when the contacts, they are separated, and to avoid the damage to these contacts, So there is a fast opening of the or fast movement of the moving contact it is required, and at the same time the interrupting medium it is injected on the earth. So during this we required a high torque to move or to pull the moving contact or to close the moving contact, so that the contact, when the contact closes, there should not be a loose connection. So high force or torque we have to apply, and it should be maintained in the closed condition. Again, while opening the contact, we required high torque. So for that purpose, spring operating mechanism, pneumatic and hydraulic mechanisms, they are used for the extra high voltage circuit breakers. The spring mechanisms were confined to the minimum oil circuit breakers, which required this 3500 to 4500 Newton meter per pole at 420 kV circuit breaker. And this spring mechanism it is also used in SF6 type circuit breakers for lower transmission voltages, means high voltage 110 kV to 20 kV. For EHV and ultra high voltage circuit breaker, especially we required the faster operation, so that the arc is interrupted within 3 cycles, 4 cycles of the circuit breaker. Nowadays 2 cycle circuit breakers they are also available in the market, so that the total break time is 2 cycle or total break time of 2 cycle, and the choice is generally limited to the pneumatic or hydraulic mechanism, because in the pneumatic and hydraulic system higher torque can be generated while closing and opening of the circuit breakers. First is a spring mechanism. So this type of mechanism or spring type of mechanism is commonly found in high or extra high voltage outdoor type circuit breakers, and practically in all medium or low voltage circuit breakers also, which are used as a indoor type circuit breaker. Extra high voltage outdoor type, medium and low voltage indoor type circuit breaker, they use this spring mechanism. So this mechanism have been used with minimum oil circuit breakers, and after that it is also adopted in the SF6 circuit breakers. The energy of this mechanism is stored in the closing spring. So this spring it is expanded or it is compressed, so it will store the energy. So this stored energy is available for closing the circuit breaker, and after following the release of the closing latch, and when the closing latch it is released, so the spring force or the energy stored in the spring it is used for the closing of the contact of the circuit breakers. So here you can see this spring mechanism. So generally 2 springs they are used in this spring mechanism. When the circuit breaker it opens the contact, at that time the closing spring of the circuit breaker it stores the energy. The spring mechanism is a simplest form. It consists of the charging motor. Here you can see this charging motor in this case. Here you can see charging motor connected with this gear. So this system it consists of charging motor and the charging ratchet, closing cam, closing spring and the toggle linkages. So it is a mechanical system. So linkages are there. So this system, the total energy is in the form of spring. It is stored, the energy it is stored in the spring for closing the contact system. Then for charging the tripping mechanism, for opening the contact system, and for building the buffer pressure in the blast cylinder. So this total energy, it is stored in the springs. One is for closing the contact and another is for opening the contact. So next is a pneumatic mechanism. So in this pneumatic mechanism, it is a best suited for the air blast circuit breaker, because in the pneumatic you required a compressed air or pressurized air, and in air blast circuit breaker, so pressurized or this compressed air, it is already available and used for the insulating and interrupting. Pneumatic or pneumospring mechanism have been adopted by a large number of circuit breaker manufacturers for SF6 gas circuit breakers, and this pneumospring mechanism, it is having a piston used to drive the opening linkages and charge a set of closing spring. So pneumatic cylinder, pneumatic piston, it is used with the control valves to open the linkages and to charge the closing spring, to store the energy in this closing spring. So in order to close the circuit breaker, high pressure air is applied to the underside of the piston. By opening a three-way valve, the piston moves downward. So while opening, this piston will move in the downward direction, and for that the control valve, it is used. So in this figure you can see this is a cylinder, and this end of this cylinder or piston, it is connected with the mechanical linkages. Plunger extension for hand operation, or it is connected to the spring mechanism. So here you can see air inlet, here pressurized air is connected to this valve. This is a main valve block, this is a valve body, this is a cylinder, and these are the toggle mechanism and resetting springs in this pneumatic system. So this is a pneumatic operating mechanism to open or close the circuit breakers. Next is a hydraulic mechanism. The energy is stored in a nitrogen gas accumulator, and incompressible hydraulic fluid become a fluid operating link that is interposed between the accumulator and a linkage system. So similar to this pneumatic cylinder, here the hydraulic piston or hydraulic cylinder is there. Hydraulic motor is there to generate the hydraulic force by using this hydraulic fluid. Okay, so which will operate the link through this hydraulic cylinder. So a hydraulic mechanism operate at much higher pressure than the pneumatic cylinder. So as compared to the pneumatic pressure, hydraulic fluid, it can generate the higher pressure. Then leakage is important factor to be considered because fluid is conversed and recycled. So in case of air, if there is a leakage of air, so air is free available in the atmosphere and it is compressed through the compressor. But here the hydraulic fluid, it is a recycle, it is a reuse. So we have to take care of the leakages in the hydraulic mechanism system. There should not be a leakage. So here we can see the hydraulic system. 7 number, this is a hydraulic oil tank, then oil pump motor system to generate the pressure in this hydraulic system. 3 number, 4 number here, these are the valve, pilot valve to change the direction of flow or through this piston, and this is a differential piston. So this piston is extended or it is a retracted. So in this case the piston, it is a retracted, so it is at the downward direction, so that the circuit breaker contact, it is open. When we have to close, so we have to apply the force through this downward direction so that it moves in the upward direction and it closes the contact of the circuit breaker. So moving parts are protected from the external corrosion. So these moving parts, its surface should be smooth. They should not be corroded with the atmospheric air, so that the protection it is given against the corrosion. The hydraulic mechanism, as they are totally immersed in the hydraulic fluid, and the hydraulic system, it is completely sealed. This total system, it is a seal. There should not be a leakage of the oil. So there should not be a corrosion of this moving part. In this case, this moving part, it is the cylinder, or it is a piston, moving piston in this hydraulic cylinder, or this differential piston. So it is a plated with this nickel chromium, so that the corrosion it is avoided. This moving surface through this oil seal, it is very smooth. There should not be a leakage of this oil. So this is the hydraulic system or hydraulic mechanism. Next is a SF6 gas dynamic mechanism. So this system, it is developed by this NMG company of the Italy. So this is a very innovative mechanism which is being used by them for the 420 kV circuit breaker. So this is a basically single pole operating mechanism. It is used for the single pole in the three-phase supply system. The potential energy of the pressurized SF6 gas, it is used to operate the contact system of the interrupter. And during this closing and opening operation, this pressurized SF6 gas in the pole column is allowed into the upper and lower chamber of the differential piston cylinder. Okay, again here the cylinder it is there, and this cylinder it is moved based on the SF6 pressure in the upper or lower chamber. Okay, so based on that, the cylinder it is moved. The piston in this SF6 cylinder, it is moved with this pressurized SF6. And during this operation, some SF6 gas is allowed to flow to the secondary chamber, and which is later pumped back into the pole column with the help of small compressor. So here you can see the small compressor. These are the closing valve, opening valve. This is a drive cylinder, and this cylinder it will move this fixed contact. It will close or open the circuit breaker, and this is a SF6 column. So this is SF6 dynamic mechanism. Next operating mechanism, it is a motor driven mechanism. So as you see in the spring mechanism, pneumatic mechanism, hydraulic mechanism, or this SF6 dynamic mechanism, there is a lot of mechanical system is there. Springs are there, ratchets are there, gears are there. In case we required the compressor in pneumatic system, we required hydraulic motor, hydraulic in the hydraulic system. So all these mechanical parts, they are reduced by this motor driven mechanism. And this motor driven mechanism, this is under development. So this mechanism has the least number of mechanical components. And in this mechanical system, these ratchets, cams, they require the maintenance, they require the greasing at the regular interval. So that maintenance part of this mechanical component, they are reduced by this motor driven mechanism. So it is directly mounted on the linkage housing of a pole column using the capacitor bank as the energy storage device. So the operation of this motor, the electronic system, it is used to operate and control the circuit breaker. So generally this stepper motor, it is used in this motor driven system. So here you can see these are the 3 poles. Here the common linkage or common tripping bar is there, which is connected to all these 3 poles, and at one end this motor, it is used for opening and closing the circuit breaker. And here this is a control cubicle, which is a drive unit, and the energy storage unit, capacitor, it is used in this control cubicle. Okay. So this is developed by the ABB. So these pictures, they are used by the ABB. So this is the motor driven mechanism. So in this way we see the detailed classifications of the circuit breaker. So thank you for patience listening. Thank you. Happy learning.